Welcome to China Gateway, the show where we unpack how China's technology and strategy shape the world. Today we're diving into the India-Pakistan air clash and the surprising role of Chinese-built jets and systems. Okay, so let's get into this. Back in May, when this India-Pakistan air clash happened, the initial stories, well, they were all over the place. Contradictory, really.
Yeah, very confusing at first.
But then this deep dive investigation came out. It took about 4 months, published by the editor, Vance, from a major UK Air Force monthly. Seems like they really dug in, interviewed Pakistani Air Force folks.
And what they found, I mean, it sent shockwaves through military circles globally. It really did.
Because the outcome was so lopsided.
Exactly. The final score, according to this investigation, was effectively 0 to 8. Pakistan lost nothing. 0. India lost 8 aircraft.
8. Wow.
An absolute blowout.
That number, 8 losses, it's huge. Especially when you think about the politics. India's PM even mentioned losses at the UN. I think they said 7, but the report counts 8. 7 manned fighters, 1 drone.
And these weren't just any old planes India lost. That's the critical part. We're talking 4 advanced French Rafales. The report even lists their specific unit numbers: BS 001, 0211, 022, 027.
Ouch. Those are premier assets.
Premier assets. Plus a Russian Su-30 MKI, a MiG-29 UPG, a Mirage 2000. Losing that kind of hardware, I mean, that quantity of modern frontline fighters, it tells you straight away this wasn't about who had the braver pilots.
No, definitely not. A score like that, 0-8, that points to something systemic. An architectural failure, you could say.
Right. It wasn't about dogfighting skills necessarily.
It was about which side had the better network. Faster, more integrated. That's what decided.
Okay, so the big question isn't just which jets flew, but what systems were behind them. What was Pakistan's edge here?
Well, the core advantage seems to be this fully integrated system almost entirely developed by China. Think of it like a Skybrain.
Skybrain, I like that.
At the center of it was a Chinese AWACS plane, an airborne warning and control system. But it wasn't just a flying radar dish. It was like the command center, the eye of God, coordinating the whole battlefield.
And this AWACS was directing traffic from, what, 300 kilometers away? Pretty far back.
Yep. And the secret sauce connecting everything, it was the data link. Pakistani forces were using the Chinese Link 17 data technology, sometimes called DTS-03.
Link 17, so that's the network plumbing.
Exactly. Think of it like a super secure, high-speed military internet just for this battle. It connected the AWACS, the Pakistani JF-17 fighters, those are the Chinese-designed jets.
GN-1C.
Right, and the PL-15 air-to-air missiles, the long-range ones, and the ground-based air defense. Everything talking instantly, sharing the same real-time picture. Securely.
Okay, so everyone's on the same page, literally seeing the same targets from the AWACS.
And that enabled a really stunning tactic. Because the AWACS was doing all the seeing, the Pakistani pilots could do something normally unthinkable. Suicidal, really.
They turned off their own radars.
Turned them off. So they were flying blind.
Essentially, yeah. From their own sensors perspective, they became radar invisible to the Indians, relying completely on the targeting data fed to them through Link 17 from the AWACS way behind them.
That sounds like a video game where one player has the cheat code, the full map, and is just telling everyone else where to shoot without them needing to look.
Kind of, yeah. It's passive surveillance taken to the extreme. Networked warfare 101, they stayed dark, totally silent on radar until the absolute last second.
And then?
Then they unleashed the main weapon, the Chinese PL-15 missile. Long range, very capable.
And this is where it gets really interesting technically. The report says when those PL-15s launched, India's fancy electronic warfare systems, the French Rafales system on their brand new Rafales, it basically just failed.
Failed is putting it mildly. It misidentified the incoming missile signal, classified it as like background noise or a false alarm, ignored it.
And this wasn't just bad luck or a random glitch. This seems to have been by design. Targeted engineering. The PL-15 uses this very specific sophisticated frequency hopping technique.
Frequency hopping, so the radar signal jumps around.
Right. Instead of a steady signal, it's like it's doing this complex digital dance, changing frequency constantly. Makes it incredibly hard to lock onto.
And that specific dance pattern, it apparently fell right into a known blind spot, a vulnerability in that French Rafales EW system.
A known blind spot? How?
Well, the thinking is the Rafales system was primarily designed to counter older threats, Russian-made missiles, which might have more predictable radar signatures.
But China seems to have studied Western systems, treating allies like France as potential adversaries in their design simulations. They apparently engineered the PL-15 signature specifically to exploit that kind of known limitation in Western EW logic.
Whoa. Okay, that's huge. So China didn't just build a good missile, they built a missile tailored to defeat the specific defenses used by NATO-aligned countries.
It looks that way. I mean, one Pakistani official apparently confirmed the whole system OACS guiding the JF-17s using Link 17 to fire PL-15s was tested and rehearsed precisely to defeat this kind of French EW setup, combining that passive approach with missile maneuvers.
So think about the pilot in the Indian Rafale. State-of-the-art jet, top-tier EW system.
Yeah.
But the system says all clear, then suddenly they see it, not on radar, but with their own eyes. The missile contrail streaking towards them.
At that point, traveling at combat speeds, you've got maybe 3 seconds.
Max.
3 seconds.
There's not enough time to even react properly, let alone evade effectively. It's
Yeah.
game over. An architectural defeat, not a dogfight loss, caused by a tiny technical blind spot?
Okay, let's flip this. Contrast Pakistan's seamless system with what India brought to the fight.
Yeah, India's setup was fragmented, a real mix and match. You had Russian fighters like the Su-30, French jets with French radars on the Rafales, Israeli EW components, Israeli missiles maybe, all bolted together.
A panzer, as the report called it, a mixed bag. And the problem with that kind of setup is data integration. The interfaces. How do you get the Russian jet systems to talk seamlessly to the French radar data, processed by an Israeli EW suite?
Sounds like a nightmare.
It creates massive friction. The report used this striking phrase. India's AWACS, its fighters, and ground control formed 3 information islands. They just weren't speaking the same digital language fluently.
And when things got hot,
Catastrophic failure. The investigation suggests Chinese electronic warfare units managed to disrupt India's primary communication links. When they tried to switch to backups, the systems just couldn't coordinate effectively between, say, the Su-30s and the Rafales.
they couldn't share targeting data or warnings fast enough or reliably enough. No unified picture.
So, back to the video game analogy.
Yeah, Pakistan's team had flawless comms, shared screen, instant updates. India's team was trying to coordinate over laggy connections, maybe different chat programs entirely. You know who wins that fight?
Right. Which brings us nicely into busting some myths, because that 0-8 scoreline really overturned some common assumptions about air power, didn't it?
Definitely. What's the first big one?
Myth 1. It was just better jets. People might think, okay, maybe the Pakistani JF-17 is secretly way better than we thought.
But that's not really it, is it?
No, completely untrue. The JF-17 is a solid jet, comparable to others in its class. It's capable. But it's not some stealth superfighter. The difference wasn't the individual plane.
It was the system.
It was the system, the doctrine of unified command, the network warfare approach enabled by the AWACS and Link 17. That whole architecture, practiced and integrated, that's what won. System integration beat flashy individual parts.
Okay, myth 2. Well, surely Western EW, maybe American systems, would have seen that PL-15 threat?
A common thought? Maybe. More power, more sophisticated.
Not necessarily, because the key wasn't just raw power. It was about hitting that specific blind spot in the French system's logic. It's about niche engineering, knowing your opponent's potential weaknesses.
Exactly. China wasn't just building a generic good missile. They seem to have built an anti-Thales EW missile, in a way, which shows incredible insight into the opponent's tech stack. That detailed knowledge is crucial.
Which leads us to the really big takeaway, I think. Myth 3. Okay, fascinating military tech stuff, but this is only about war.
Right. Like it doesn't apply elsewhere.
But it absolutely does, doesn't it? This whole scenario mirrors huge challenges we see in complex civilian industries every single day. Manufacturing, supply chains.
Oh, completely. Think about building, say, an electric vehicle, a really advanced one.
Okay.
You might source the absolute best LiDAR sensors from Germany, right? The most energy-dense battery cells from Korea. Cutting-edge self-driving software from Silicon Valley, best-in-class components.
Sounds like a winning formula, the India approach in this analogy.
But if the data interfaces between that LiDAR, the battery management system, and the driving AI weren't designed together from the ground up to communicate flawlessly with near-zero latency, you get friction, big time.
So maybe the LiDAR data takes a few milliseconds too long to reach the AI in a critical moment.
Exactly. Or the battery system throws some weird proprietary error code that the main computer doesn't understand instantly. The result isn't getting shut down, thankfully, but it could be a delayed product launch, a massive recall, maybe even a safety failure. Billions lost, reputation damaged. Same principle. Interface risk. kills performance.
And that nails the core lesson for anyone building complex stuff today. Integration beats prestige parts. India had the fancy French Rafales, the brand name. Pakistan had the system that worked together seamlessly.
Own your stack.
Own your stack! Or at least ensure the data plumbing between the parts is absolutely perfect. Minimize that third-party interface risk. That's where the real value and the real danger lies.
And the speed of that plumbing is everything. Data latency matters. Link 17 worked because it was fast and reliable over huge distances.
Like on a modern factory floor?
Precisely. If your inventory system takes too long to tell the robots what parts are needed, or if the quality control sensors lag in reporting defects, you lose efficiency, you lose quality, you lose money. Same problem, different context. Low latency, reliable data flow is king.
So, stepping back, what does this tell us about, say, partnering with Chinese companies, if you're a business or even another country looking at Chinese tech?
Well, it suggests that often you're not just buying a component from China. You might be buying into a whole system, an ecosystem.
Right. Like if China provides the sensor, the network, and the processor.
They've likely engineered out all that internal interface friction from the start. They control the whole stack. The performance ceiling can be incredibly high because it was designed as one unit. This battle kind of proved that principle in a very stark way.
And look at India's reaction. It confirms the analysis, really. They immediately went back to France asking for an urgent EW upgrade for their Rafales.
Makes sense. Fix the vulnerability.
But get this. The reported timeline from France. 18 months. Due to, European production schedules, existing commitments, slower industrial lines.
18 months.
18 months just to patch the known flaw. Meanwhile, Pakistan is apparently accelerating orders for improved JF-17s, potentially with even longer-range missiles like the PL-21.
Wow, that contrast in speed and responsiveness, it's staggering. One side leverages rapid integration for a decisive win. The other faces an 18-month delay just to catch up on defense.
It really highlights the difference between maybe a more vertically integrated, state-driven industrial model and the complex, perhaps slower, multinational supply chains common in the West.
The bottom line seems pretty clear. In any complex high-stakes system, friction is the enemy. Integration is the weapon, whether it's jets or supply chains. So for everyone listening, especially if you work in defense tech, aerospace, supply chains, or any kind of complex manufacturing, we want to hear from you. Where does integration bite you? What are your biggest interface risks? Let us know in the comments. And if this deep dive has you thinking harder about your own operations, comment SPPLY for a China sourcing checklist we've put together, or comment market for our China go-to-market brief. Thanks for listening to China Gateway. What's your take? Would you trust a fully networked battle system built in China? Drop a comment and subscribe for more China Meets the World stories from China Gateway.